Here we go. The first three questions for your Chapter 7 test review worked out for you in their entirety. I'm going to use the TI calculator, TI-84, or the TI Inspire for my work on this one. So if you're watching this video and you're from a different class, you may need to show all your steps. I've got previous videos for that. On mine, I'm going to show you the setup and then the answer that I got. If you have any questions, you can just add a comment to the bottom of this video. I'll be more than happy to answer. First question, the velocity in meters per second of a particle moving along the x-axis is given by the function where the velocity is equal to 11 sine t from 0 to 2 pi. Find the particle's displacement. In other words, where'd the particle end up? How far did it move from beginning to end? Not its total movement, just from its original position to its new position, what was the distance covered? Okay. In this case, what we want to do is find the integral of 0 to 2 pi for 11 sine t. If we were looking for the total distance covered by this particle, we would definitely put some absolute value bars around that. But we don't need the absolute bars around this because we just want to know, where did it end up? Okay, where did it end up? How far did it move from point A to B? Not how did it meander, just it started at 2, it got finished at 3. That's 1 unit. So how far did this guy go? Well, if you graph this and look at it from 0 to 2 pi, it's actually 1 period of the sine curve. And if you have the same amount of stuff above the axis that you do below the axis, when you add the positive and negative values together, you get 0. So what was the displacement for this guy? 0. Okay, he started where he stopped by the time all the movement was done. Now, if we wanted total net movement, like where did he go in between 0 and 2 pi, how far did he travel total, then we would just do the same integral and do the absolute value. So here's a bonus freebie, just absolute value of 11 sine t. So when you punch that guy in, that'll give you the total distance. I'll go ahead and do that on mine right now. And I get something along the lines of 44. So 44 units of space were covered. In this case, we're talking about meters per second. So when I integrate back up, I lose the seconds, yikes, and I'm left with meters. Okay. Question 2 then is the same sort of question. It is, here's the function, is the velocity in meters per second of a particle moving along the x-axis. Find the total distance traveled by the particle. Here's your total distance question. So if we want a displacement, we would just go from 0 to 2 and integrate what we see. Since we want total distance, that could be a different number altogether. We're going to go from 0 to 2, absolute value, 3t over 1 plus t squared. Dt. And so I punched that guy into my calculator, and when I did that, I got 2.4142. And since we're in meters, he would also be in meters. Now, if you had to find an exact answer, the exact answer for this guy would be 3/2 times the natural log of 5. And because of that, we're looking at a partial fraction decomposition situation on this guy, which is why you would have the natural log in there. Find the area of the shaded region. Now, there's 2 ways to do this, the easy way or the hard way. I'm going to go with easy. And when I look at this problem, I want to do a top equation minus a bottom equation. Unfortunately for us, if we look at it how we like to integrate and are used to integrating, we're looking at a situation where we're going to have 2 separate equations that are on top. This guy right here, which would be y equals 3x, and the other guy, which is going to be y equals 4. That means that we have to integrate twice and add those 2 things together. The other thing that we could do is we could just say, hey, you know what? I'm going to look at this in relation to the y-axis. And if I look at this in relation to the y-axis, then all I need to do is do my right equation minus my left equation. Okay, right minus left. Well, they gave us the equations. So on the y-axis, we start at 0, we go to 4. That's where we're going to integrate. We're going to integrate from 0 to 4. Okay? And not only we're going to integrate from 0 to 4, we're going to do the right equation minus the left equation. Well, solve these out. So if I have y equals 3x, I need it to say x equals. This one's easy. It's y divided by 3 equals x. On the other guy, I've got y equals x squared over 2. So this is going to be 2y equals x squared. And then take the square root of both sides. So the square root of 2y equals x. And it's plus or minus. Okay. Now, since we're in first quadrant, we take the plus square root of 2y. So my problem then becomes my right equation, which is this parabola shape. So the square root of 2y minus the left equation, which is y over 3. And I punch this guy in, and I get for him 4.876 units squared, because that would be the area. The other thing that we could do is we could go ahead and give an exact answer on that. And so the exact answer that I have is 16 squared roots of 2 over 3 minus 8/3. Okay. And again, there's two different ways to go about this guy. I think if we integrate with respect to y, it's quite a bit easier to work out. So there's your first 3 questions.